Welcome to my YouTube channel, and I started a new series called the AP Chemistry Question of the Day series. So in this series I'm going to talk about typical things that students get wrong when they are doing the AP Chemistry questions. So today my first question is about electron configuration. So electron configuration describes how the electrons are organized outside the nucleus. So we have shell, we have subshell, and we have orbitals. And there are three rules you need to follow while writing electron configuration. The first one is called the Aufbau rule. So the Aufbau rule tells you the electrons always fill in the lowest energy orbital first. And then they will fill orbitals with higher energy. But for ground state, they always tend to go to the lowest energy orbital, because and orbitals with the lowest energy will have a stronger attraction from the nucleus. The second rule is called the Pauli exclusion rule. The Pauli exclusion rule tells you no two electrons can have the same 4 quantum numbers in an atom. So in another word is, in one orbital you can only fit in 2 electrons, and the 2 electrons has to be opposite spin. And the last rule is called the Hund rule. The Hund rule is like 4 orbitals with the same energy. Like there are 3 orbitals in the p subshell. There are 5 orbitals in the d subshell. If the orbitals have the same energy, then electrons will fill in separate orbitals with the same spin before they pair up. For my question here, I have 4 transition metal ions. I want to find out which one has the most unpaired electrons. Before we do the ions, first we can write out the electron configuration for the metal atoms. So for cobalt, it will look like 4s2, 3d7. The electrons fill in the 4s subshell first, even though it's in the 4th shell, because 4s has lower energy than 3d. And 3d has 5 orbitals, and I have 7 electrons, so 2 of the electrons has to be paired up. And for iron to iron, then it will be argon 4s2, 3d6. So for the 5 3d subshells, only 1 of the orbitals has a pair, and all the other 4 has only 1 electron in them. And then for zinc has 10 3d orbitals. So zinc will be 4s2, 3d10. So for the 5d orbitals, all of the electrons have to be filled in pairs, because you have only 5 orbitals but you have 10 electrons. And for manganese, it's argon, and then 4s2, 3d5. In this case, I have 1 in each orbital. These are electron configurations and orbital diagrams for the only for the 3d subshell, because in the 4s you have only 1 orbital and all the electrons would be paired. And then now I'm trying to figure out the electron configuration for the 2+ metal ions. So for transition metals, and for anything in the p block as well, always remember, when you're trying to form cations, you have to remember you're always lose the outermost electrons first. Outermost electrons means electrons with the highest n. So outermost electron means the electrons with the highest n, or the outmost shell. So in this case of the 4 transition metals, even though the last electrons were filled in the 3d subshell, but 4s is further away from the nucleus, they are more readily to be lost. So we are losing the 4s2 for all of them. So as a result, manganese 2+ will have the most unpaired electrons, because their 3d subshell wasn't even touched when forming that cation. Did you get this question right? Thank you very much. Keep posted. I will post more questions of the day. Thank you for watching. Bye.